two moving toys of masses 50 kilogram and 30 kilogram are traveling on the same plane with speeds of 5 meters per second and 3 meters per second respectively in the same direction. If they collide and stick together, calculate their common velocities. From the principle of conservation of momentum, we know that m1 u1 plus m2 u2 is equal to mv into m1 plus m2. Now this is obviously because they stick together. So we know that m1 is 50 times u1, which is 5, plus m2, which is 30, times u2, which is 3. This is equal to v into m1, 50 plus m2 as 30. So 50 times 5 is 250 plus 30 times 3, that's 90, is equal to 50 plus 30 is 80. So we have 80v. So divide both sides by 80. So we have 250 plus 90, that's 340, is equal to 80v. Now divide both sides by 80. And dividing both sides by 80, v is equal to 4.25 meters per second. Question 2. Two balls of masses 0.5 kilogram and 0.3 kilograms move towards each other in the same line at a speed of 3 meters per second and 4 meters per second respectively. After the collision, the first ball has a speed of 1 meters per second in the opposite direction. What is the speed of the second ball after collision? Now, consider the first ball, A, moving in the right direction and the other ball, B, moving in the opposite direction. Now, the mass of the first ball is 0.5 kilogram, okay, and m is equal to 0.5 kilogram, and this initial velocity of the first ball is 3 meters per second. Then the first ball, the mass m2 is equal to 0.3 kilogram. Now the speed of the ball of the second ball u2 is equal to, because it's moving in the opposite direction to the first one, it's going to be minus 4 meters per second. Now this is going to be equal to, now after collision, the first ball moves in opposite direction to the direction of the first ball. So we're going to put this, that's A, moving in the backward direction. So that's the final velocity V1 of the first ball is going to be minus 1 meters per second because it is moving in the opposite direction. Then plus the speed of the other ball. Here we do not know the direction of the speed of ball B. So from the principle of conservation of momentum, we know that m1 u1 plus m2 u2 is going to be equal to m1 v1 plus m2 v2. I'm using this obviously because it is an inelastic collision. They didn't stick together. That's why they move in opposite direction after collision. Now m1 is 0.5 times v1 3 plus m2 is 0.3 times v2, that's going to be minus 4, is equal to m1, that's 0.5 times v1, that's times minus 1, plus m2, that's 0.3 times v2. 0.5 times 3 is 1.5. Plus times minus is minus. 0.3 times 4 is 1.2. That's equal to 0.5 times minus 1, that's minus 0.5 plus 0.3 V2. Now, 1.5 minus 1.2 is 0.3 is equal to minus 0.5 plus 0.3 V2. Take minus 0.5 to the other side. We have 0.3 plus 0.5 is equal to 0.3 V2. 0.3 plus 0.5 is 0.8. That's equal to 0.3 V2. So divide both sides by 0.3. And V2 is equal to 0.8 divided by 0.3. That is 2.6666 recurring. So I'll just approximate that to V2 is equal to 2.67 meters per second. 3. A gun of mass 100 kilogram fires a bullet of mass 20 grams at a speed of 400 meters per second. What is the recoil velocity of the gun? Now, we know that the mass of the gun, big M, is equal to 100 kilogram. And the mass of the bullet, small m, is equal to 20 divided by 1000. We have to convert it to kilogram. So that gives us 0.02 kilogram. Now, the speed of the bullet, small v, is equal to 400 meters per second. Then the speed of the gun, big V, is unknown. So we know that V is equal to small m all times small v divided by big M. So small m is 0.02 times big V, small v is 400 divided by big M, 100. So these zeros, V is equal to this zero will cancel out this. So we have 0.02 times 4, that's 0.08 meters per second.